Hey, Miss Marion here. We are going to be talking about slope triangles, but pretty much we're doing Unit 2, Lesson 10 and 11. And I decided to go ahead and pick different pieces to go along with it. So make sure you follow along in your workbook and make sure you know what page that we're actually on. So let's turn back to page 123. And we're going to read the I can statement, so page 123 in the back. There's two of them. I can draw a line on a grid with a given slope, and I can find the slope of a line on a grid. So this is our I can statements for today. So go ahead and give yourself a number. So 1, I don't remember. 2, kind of remember it. 3, I do remember it. 4, I can teach it to my friend. And then also write yourself a sentence on how you feel about that, so you know how you're doing before and after this lesson. So as we have kind of said before, if we can look at it, the slope, this is the really mathematical definition. It's the quotient of the vertical distance and the horizontal distance. But we talked about that it is the fraction of the vertical distance over the horizontal distance. And we actually did this yesterday. So I like to say the slope is the vertical distance and it is being divided by the horizontal distance. So again, one of the other thing about similar triangles is that notice, and we did this yesterday, notice how we have a vertical distance here and a horizontal distance here. And then we have a vertical distance and a horizontal distance. Notice how these two triangles, they are different as far as right triangles. But again, when we were doing this yesterday, if we took that fraction and reduced it down as much as possible, then it actually was exactly the same. So this is actually what we're going to go ahead and look at for today. So let's go ahead and let's turn to page 87. And on here, we're going to draw two lines with a slope of 3. So 2 lines, slope of 3. So remember, with our slope, we need it in fraction form. So we have 3, right? How do I put 3 in a fraction form? Remember, we can put it over 1. So go ahead and write 2 lines with, or draw 2 lines with a slope of 3 over 1. And remember, it's a vertical distance or over horizontal distance. All right, so I'm going to go ahead and do this. So I have a vertical distance of 3. So 1, 2, 3, horizontal distance of 1. And I'm going to connect these two lines together, or these two kind of where I started and where I ended points together, and it's going to draw my line. So here is my slope triangle of 3 over 1, and then I'm going to do that again. So, and it doesn't matter. So here's my 3, here's my 1. Okay, and what do I notice about these two lines? Well, they are exactly the same. So no matter where I draw a slope of 3 over 1, those lines are going to be exactly the same. That's kind of what we noticed yesterday. Let's go ahead and do this again. We're going to do it with a slope of 1/2. So go ahead and draw 2 lines with a slope of 1/2. So I have a slope of 1. Here's my 1. Here's my 2. And again, I'm going to do it one more time. Here's 1, 2. And again, if I look at these two lines, again, they are exactly the same. All right, so let's look at page 88. So it says, here are several lines, and it says match the lines shown with the slope. So I have 1/2, I have 2, so remember 2 is same as 2 over 1. I have 1, that's the same as 1 over 1. I have 0.225. So 0.25, let's go ahead and change that into a fraction form. 0.25 is the same as 1 over 4. And then we have 3 over 2, and then we also have 1/2. So these are all the different slopes. And then if we read number 2, it says one of the given slopes does not have a line matched to it, then we need to go ahead and draw that. So go ahead and go through A through F, match the slopes, and then draw the last one on F. All right, so let's go ahead, let's look at A. So A, my vertical is 1, 2, 3, horizontal is 2. So this slope is 3 over 2. Let's look at B. My vertical is 2, horizontal is 1, 2, 3, 4, 5, 6. So here's my slope of 2 over 6. Is that one of the ones I can choose from? It is not, but can I reduce that down? Let's put it in our calculator, press enter. What does it reduce down to? 1 over 3. So right now we have done 3 over 2, and we've done 1 over 3. Let's look at C. C, my vertical is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my slope is 5 over 5. Is this a skinny or fat fraction? That is a fat fraction. And it reduced to 1 or 1 over 1. Now let's look at D. D, we don't have any points on there, or we don't have a slope triangle or that right triangle. Let's go ahead and pick 2 points. Let's do this instead. There we go. And on the line and also on the grid, we're going to go ahead and draw our right triangle. And then we have 1, 2, 3, 4 over 1, 2. So then my slope is 4 over 2. Can we reduce that down? Yes. Put it in your calculator. Press enter. You're going to have 2, but we want to write it as a fraction. So it's going to be 2 over 1. Let's go ahead and look at E. So again, with E, I'm going to pick 2 points. And again, it has to be on the grid and on the line. Draw my right triangle. Here is 1, 1, 2, 3, 4. Here's 4. So that slope is 1 over 4. And that was that same as that 0.25. All right, so we have 3 over 2. We have 1/3. We have 1 over 1. We have 2 over 1. And we have 1/4. So which one is missing? So the one, so we have 3 over 2. We have 1 over 3. We have 1 over 1. We have 2 over 1. And we have 1/4. So what is missing is 1/2. So let's draw that. So I have, I know I'm going to have a 1 as my vertical. And I need 2 as my horizontal. And I can connect those together. Okay, so this is what we should actually have on page 88. So again, vertical over horizontal, that is slope. And no matter what slope triangle we have on that same line, as long as we reduce that slope, those slopes down, all of those different slope triangles are exactly the same. So let's turn to page 95. So on page, and so we're going into lesson 11. So on page 95, what are the coordinates of B and D? So what are the coordinates of B and D? So B, that coordinate is 4, 3, and D is 8, 6. So on here, what we want to see is we want to talk about the slope. And we want to see if certain points are on the line. So notice how this goes through 0, 0. Notice how this slope triangle, my slope triangle is 3 over 4. And let's draw another slope triangle with D. So our vertical is 6, horizontal is 8, okay? And so let's look at the slopes of our red triangle. Vertical, which is 3, horizontal, which is 4. Let's look at the slope for our blue, which is 6 over 8, which also reduces down to 3 over 4. So notice how, because it goes through 0, 0, we can see if certain points are on the line. And the way that we do that is if the slope is the same. Okay, so if we look at number 2, it says is 20 comma 15 on this line, and this only works when it goes through 0 comma 0. So what we're going to do is we're going to say, okay, our slope is our vertical over horizontal, or the change of y over the change of x. So I need to put my y, so remember x comma y. So we're going to say 15 over 20. So grab your calculator, put 15 over 20 in your calculator, press enter, and let's see if it makes that same slope as 3 over 2. So tell it, put it in, press enter. Does this reduce down to 3 over 4? Yes, it does. So is this the same as the red slope and the blue slope? Yes, it is. So is 20 comma 15 on that line? Yeah, it is. All right, so let's try number 3. So again, we did our slope. Remember, it's our change of y over change of x. So I need to go ahead and put my y stuff first. We're going to say 75, 100. And again, this only works when the line goes through 0 comma 0. We'll talk about it a little bit later with other stuff. So let's go ahead. Let's put 75 over 100 in our calculator. Press enter. So we're going to go ahead and simplify that down. So we're going to go ahead and it reduces down to 3 over 4. So is it 100 comma 75 on this line? Yes, it is. Let's go ahead and try number 4. Same kind of thing. Our slope is our change of y, which is 68, over change of x, which is 90. And let's go ahead, let's put that in our calculator. Now, what does that reduce down to? 34 over 45. Is 90 comma 68 on this line? No, it is not. So we can make slope triangles with these. And again, this only works where it is 0 comma 0. But notice how we can make all of those slope triangles as long as that line is. And does it go through? Is it the same slope? No, it is not. And again, we're looking at the change of y over the change of x. So again, we're just looking at our slopes. We're drawing slopes on a line and looking at those kind of things themselves. So let's go ahead and go back to page 123 and go ahead and give yourself a number about how you feel about what we covered for today. So 1, I can draw the line on a grid with a given slope, and I can find the slope of a line on a grid. So go ahead and give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. 4, I can teach it to my friend. So for today, we are doing lesson 11. We're doing numbers 1, 2, and number 3. On number 2, do not do E. It talks about in an equation. We haven't done that yet. I want to actually go over that tomorrow and the next day. But again, we're doing numbers 1, 2, and then cross out E on number 2, and then also do number 3. And this does go put into Canvas. Why? Because it corrects you and you know if you're doing it correctly. Okay? And again, that's what we did slope for today. So go ahead and have a good day. Bye.